Okay, now that we have built the infrastructure, let's actually build the API and the implementation for our first queries and the handlers. So we define a new file called application.fs, and this file should hold the query API and its implementation. So the first question that we need to ask ourselves is, what kind of queries do we want to implement? So let's have a look at our example program. And here we have two things that we want to know about our business. How many portions of a given flavor we have in stock for a given truck, and how many portions of a flavor did we sell for a given truck. So let's actually implement those. Having a language with some types, this is our easiest exercise. We implement both queries with a new type called truck. Find it in our domain yet, so let's do this now, and I think that it will come in handy later anyway for our events and our commands. So let's implement the query handler for those queries. Again, in order to be able to have a query handler, we need to create a record with a single handle function that takes a query and returns an asynchronous query result. So let's do this. In our handle query function, we match over the query. And because we only have two queries yet, we can get an exhaustive pattern match pretty easily. The question is now how to actually implement those queries. So again, let's have a look at our current implementation. Here we use the event store to get the corresponding event stream of a given truck, and then we use one of our already implemented projections. So let's just do the same in our query handler. We need the event store, so let's make this clear in our parameter list. And then we use the stream and a projection from our projection module, in this case the flavors in stock projection, to get the current state that is important for the query. And the status of type map from a flavor to an int, so we can just try to find the given flavor, and if it's not in there, we can just return 0. But of course that's not enough, because we need to wrap the result in a query result. And we are doing this by using the handled constructor, which means that our handler was actually able to handle the query. And let's see, it's still not compiling. And the reason is that we are expecting an object and not an int. So let's cast this up with the help of the bugs function. So why is it still not working? Of course, we need to destructure the truck part of the query to be able to get the actual GUID that is needed for the event store. And now we need to implement the flavor sold query, and this can be pretty much copy and pasted. We only need to change the projection here. But the query is still not compiling. Why? Let's have a look at the error message. The result of our query handler needs to be an async of query result, and we are only returning a query result. The event store is still completely synchronous, but we will fix this later in a later episode. But for now, we can just again wrap the whole query handling mechanism into an async computation expression and use the return keyword to return an async of query result. Later on in the series, we will actually have real I/O operations like database or file access, where all this work to have async values will make much more sense. Alright, cool. Now that we have implemented our query handler, let's use it in our actual program. And the first thing we're doing is to change our code to work with the truck data type we created earlier on. We will just implement new helpers here to get the actual GUID that we need when we talk to the event store. Now that we have done this, let's actually use the query handler. First of all, we need to create it by calling our initialize function. Just to remember, this function gets a list of query handlers. For now, of course, we just have the one that we have just created. To make it work, this function needs our event store as a parameter. Now we can replace our direct call to the event store followed by the projection, this one here, with our freshly created query handler and pipe the result into a helper function that takes an async query result, awaits the result here, and prints its value. So to show you that everything works by now, let's go back to our lovely little user interface and send a query to our system. As you can see, the result is 0. So let's actually do something in our domain. Let's restock some flavors, sell them, and when we send the query again, we see that we actually get some sensible results. Awesome! To summarize what we have done, we have created a query handler and gave it to a new entry-level query handler that is able to ask all its handlers whether they are able to actually handle a specific query or not. The implementation of our application-level query handler uses the already well-known live projection mechanism to actually answer those queries. But now we want more. We want to know not only the stock and how many of one flavor we are sold for one truck, but for our whole fleet of trucks at once. But now we have a problem. To be able to answer those questions or queries, it is not enough anymore to go through only one stream of events of one truck. We need to actually go through all the events of the system to answer one query. And we have to do this for every query again and again and again and again. And this is not very smart, I think, and it's definitely not very performant. So it would be much, much nicer if we had a way to store a state in our system that we could just ask for a specific value. And this is exactly where read models come into play. But for now, we just call it a day and tell the query handler that all except the already implemented queries cannot be handled by it. And we can check the results when we add those queries to our application, send one of those queries to the system, and see that the result is not handled. Alright, we have implemented our first query handlers in our event source system. But from here on, I think that we really need some read models. So we want to implement some new queries, and as I just said, we don't want to iterate over the whole event stream every time we actually put a query into our system. So I think that's a perfect motivation to introduce read models, and this is what we are going to do in the next episode. I hope to see you there. If you like my video series, please make some advertisement, put it on Twitter or somewhere else, subscribe, it really helps me. So thanks a lot, see you in the next episode, bye bye.